Testing, testing. Yes, we got audio. All right, so sketch the region bounded by the following. And we have one inequality is x minus 9y squared greater than or equal to 0. The other is 1 minus x minus 8, the absolute value for y greater than or equal to 0. Okay? And then find its area. So when we solve this problem, we can sketch it. To sketch it, you can go one of two ways. You can either use the graph program to enter these inequalities in relation. You can actually enter it the way it's written. The way to enter greater than or equal, you just type in the symbol greater than and then followed by the symbol equals in the graph program, and you can graph the relation. If you do so, you're going to find out that the region looks like this. Okay. This is a horizontal parabola. This one actually we're gonna write it as y equal f of x later on. But as a vertex, I'm trying to remember at 0, and so it looks like this. Okay. And this one is a line. Now, the absolute value of y, you need to consider two cases. One, y is positive, and two, y is negative. Because the absolute value, we're going to always return a positive, but y itself can be either one or the other. And it looks like that. It's going to be a line, like so. And when y is negative, it's going to be this line. So you come up with this idea or this sketch by looking at the graph program. Now, let's say you don't have the graph program, which you all have. How else we can graph this thing? Well, we can graph it by writing these relations in terms of function, y equal f of x. Notice that neither one is a function because the parabola x minus 9y squared failed the vertical line test, as well as the relation 1 minus x minus 8 absolute value of y greater than or equal to 0 fail the vertical line test. So, but if we take just the positive value of y, in other words the top half, then we do have two functions. Okay? So we're going to write, so suppose y is positive, like so, greater than or equal to 0. Now we can look at the functions. Okay, so let's look at first x minus 9y squared is greater than or equal to 0. We solve for it, right? And if you solve for it, you get x is greater than or equals 9y squared. Divide by 9 and take the square root, and you end up having y is less than or equal the square root of x divided by 9, which we can write as square root of x over 3, or, which we'll ignore, y is greater than, we can take the negative part, so it will be greater than negative square root of x over 3. Okay? But that will be the negative part, so let's write it here, and we'll ignore it instantaneously because we want to deal with y that is positive. So in this case, y will be negative. So we're looking at the top, we're looking at the top parabola or the bottom branch of the parabola. Okay, so what we came up with the following. This branch right there, okay, this will be y equal the square root of x over 3, and this one, the bottom, will be y equals negative square root of x over 3. Okay. This part, I'm not sure that that you need it, but let's see, do you actually need this part? Yes, you're probably going to need it. So I'm not wasting your time. Now let's look at the second relation, the one with the absolute value. Again, remember that we operate under the supposition that y is positive. Okay? So we're looking at this one, and this looks like a line. Indeed, it's going to be equal a line. If you solve it, you look at this. 1 minus x minus 8 times the absolute value of y. Again, we take a y being positive, so can remove the absolute value. If y is positive, there is no need for the absolute value. So now we solve for y, move it to this side, and get 8y is less than 1 minus x, and y is less than 1 minus x over 8. So this is a line with the intersect at 1/8, y-intersect at 1/8, and the slope of negative 1/8. And you can see the slope is negative. The y-intercept will be 1 over 8. So this is the line. So again, we are looking at this line. This line will be y equals 1 minus x over 8. And this one, this branch, is applied when y is negative. So y equals negative 1 minus x over 8. So we cover, now we know all 4 functions that make up the relation. Of course, we're looking at the parabola, and x is greater than 9y squared, meaning that we're looking at the right side, and we're looking at y, we're looking at this relation. So this is the area. Now, we need to find this intersection, because if I'm looking just to calculate the area, let's say above the x-axis and multiply by 2 because of symmetry, I still need to find, I need to divide the area into 2 pieces, like so. Okay? So, what is the intersection? To find the intersection, the easiest thing to do is actually stay within the relation and equating x. We can equate y to y, but then I need to equate this y to this y, and it may be a little messy with the square root. It's easier to extract x from here and extract x from there and equate each other. Again, under the premise that the supposition that y is positive, we can say that x minus 9y squared equals 0 gives us x equals 9y squared, and 1 minus x minus 8y equals 0 again, because y is positive. We're going to get x equals 1 minus 8y, and now we're going to say that we equate x to x, and we get 9y squared equals 1 minus 8y. Or solve the quadratic equation, 9y squared plus 8y minus 1 equals 0. So we need to solve this, and although this is factorable, because this solution is rational solution, it's not that easy to factor it because the factor involves fraction. Okay? Although you can say this will be a 9y plus something times y plus something else. Okay? Actually, you can factor it. Come to think about it, we don't need quadratic formula here. Okay, let's solve 9y squared plus 8y minus 1 equals 0. 9y squared can be made by multiplying 9y by y. And 1 is 1 times 1. So we need either positive 1 or negative 1. So because we have 8y, let's have 9y minus y and equals 0. So actually we can solve it like that. We don't need the quadratic formula. In the morning at 8 o'clock, it was too early and I did the quadratic formula. I didn't think it through. So, but now we have two solutions. One is 9y minus 1 equals 0, and therefore y equals 1 over 9. The other solution I'm going to ignore. And why will I ignore it? Because y equals negative 1, so we're going to ignore that one. We're going to take y equals 1 over 9. And now to find the x value, remember we end up having, we started that x equals either 9y squared or, so it's equals to, or 1 minus 8y. So if we plug in y equals 1, 9, you have 1 minus 8 over 9. We end up having 1 over 9 as well. So the intersection will be the point xy equals 1 over 9, comma 1 over 9. Now, the rest, as far as integration, let me just magnify the image right here. Okay, you have the parabola right there. This is y equals square root of x over 3. And you have the line coming from the top. And this is 1. And this is 1 over 9. So we have two regions. One region is this one. The other region is this one. So we'll call this region A1. We'll call this region A2. And remember that we need to multiply it because we have the same thing at the bottom. Okay? So the area will be 2 times A1 plus A2. So what is A1? Well, A1 is the integral from 0 to 1 over 9. We are looking at the area under the square root of x minus over 3. And what is the area right here? Is the area under this line. Remember, this line was y equals 1 minus x over 8. Okay? So it will be plus the integral. This time we go from 1 over 9 to 1 of 1 over 1 minus x over 8 dx. And that's it. I'm going to stop here. I'm not going to calculate it because this is something that you can do by yourself. Okay. So this is the solution. Now, as I said, I agree, this is rather challenging solution. Those of you well, I calculated it this morning and I came up with this solution. So, I agree, it's not an easy problem, but it's Calc 2 level challenge.